So the topic for today is this concept called percent yield, theoretical and percent yield. The theoretical yield is the maximum amount of product that can be produced from a given amount of reactant. This is the answer that we find when we do a mole-to-mole or mass-to-mass stoichiometry problem, or any typical stoichiometry problem. When you get to the end of the calculation, you get a value for how much product you can form, or if you're doing it the other way, how much reactant would be needed. But in the case of the products, that amount, that maximum amount of product, is called the theoretical yield. Theoretically, starting with a certain amount of reactant, this is how much you should get out. And that theoretical yield is based on the concept of there being a limiting reactant that runs out and stops the reaction. So if you're given two different reactants to work with, you first have to determine which one is limiting, then calculate the theoretical yield based on that. Or if you're just given one reactant, you can assume that that's the limiting reactant, and the answer you get for the calculation is the theoretical yield in that case. So the theoretical yield is just that. It's the mathematical possibility of how much product you could have formed. Of course, in the real world, things don't get to their theoretical maximum because nothing goes perfectly. So you get an actual amount that's somewhat less than the maximum, called the actual yield. And then we want to do a calculation to basically determine how well the reaction went. What was the efficiency of the reaction, or in essence, to grade the reaction. And we do this with a calculation called percent yield. The percent yield is the actual yield, how much did you actually get when you perform the reaction, divided by the theoretical yield, the number that the math told you could possibly get, and then we multiply that value by 100 to make it a percent. So the amount you actually got divided by what the stoichiometry told you could possibly get as a maximum amount, divide those two numbers, and then you multiply by 100 to make it into a percentage. So just to use an example here, if we have this combustion of propane reaction, and we want to know our theoretical yield of carbon dioxide based on a starting amount of 50 grams of propane. So we have 50 grams of propane. Propane has a molar mass of 44 grams, 3 carbons, 8 hydrogens. 50 divided by 44, 1.14 moles of C3H8 propane. We're going to multiply that by the coefficients for the mole ratio. And remember, these numbers for the mole ratio always come out of the balanced chemical equation. Our unknown, what we're trying to find, is the CO2. That has a coefficient of 3. Our known, we were given 50 grams of propane, so that means we're going to use coefficient of 1 on the bottom here in the denominator. 1.14 times 3 gives us 3.41 moles of CO2, starting with 50 grams of propane. We're going to multiply that back times the molar mass of CO2, our unknown, which also happens to be 44 grams. So 3.41 times 44 gives us a value of 150 grams. That's rounded slightly. But that is this answer, the answer you get in this box, or if you were stopping with moles, it would be in the moles box. These numbers are your theoretical yields. This is how much you could possibly get as a maximum. If everything went perfect, starting with 50 grams of propane, you could theoretically get 3.41 moles or 150 grams of CO2. So that's, in a perfect world, what you would get. Now, the theoretical yield is 150. The actual yield, when we did this experiment in this hypothetical question here, is we actually got 140 grams. So we want to know, well, how well did we do? We expected to get 150, we only got 140. So we take the actual yield given to us of 140 grams, and then we divide that by what our stoichiometry told us was our theoretical maximum of 150, and then we multiply that by 100, and we find that we achieved an efficiency of 93.3%. That's pretty good. Okay, so you're always taking the number that you're given as an actual yield. And in a problem, this would have to be given to you, or in the lab, it would be what you actually got when you did the experiment. And then you divide that number by the amount that the stoichiometry calculation told you could possibly get. Then you multiply by that 100 to make it a percentage, and that is your percent yield for these problems.